Today we're going to be looking at a geographic example using the Hume Knowledge Graph platform. So today I want to take a look at some city bike data. So if you're not familiar, these are the public bikes which are available in most major cities to be able to ride around, and so we have public data for many of these bikes. So in particular, today I want to assume the role of a city planner looking to understand how different bike routes might be needed in certain parts of a given city. So my data model involves a few simple elements. I have rides, which start and end at some station. And then within this station, I have either a total number of rides between two stations or a total number of rides per day in the station. And then we've also utilized Uber's H3 hex system to be able to also understand which stations are located in a particular hex. So we have this located in relationship into a given H3 hex, and then these hexes have neighbor hexes. We can also use Hume's perspective feature to then implement things like virtual relationships. So in this case, I have multiple aggregations of the same data, but across different time intervals. So here, my default is rides per day, but then I can also use virtual relationships to then either calculate for rides per month or rides per hour, whatever might make sense for my given use case. But today we're just going to use the simple has ride day. So now I'm going to go into my visualization and we'll see I have this simple schema. I'm going to start by enabling the geospatial setting. And so today in particular, we're focused on Jersey City and Hoboken and bike traffic between these two. So I'm going to start by overlaying my H3 hexes over top of my map. So now I can see which hexes are where. And then I'll additionally add in my hex nodes, which are generating this underlying hex data, or this hex grid rather. So let's get our hexes. So now we have an H3 hex for every single hex on our map. So I'm going to use these to actually find the stations which are most relevant to me. So specifically, I'm going to kind of select an area in South Jersey, Jersey City rather, and we're going to get the stations for it. And then I'm going to move up into kind of southern Hoboken and grab the stations here. Great. So now that I've done that, I don't really need my hexes anymore, so I can remove these in a couple different ways. So one, if I want to bring these back quickly, I can simply toggle them off of my screen. However, having them be toggleable will still consume some resources, and I want to be as efficient as possible. So in this case, I'm going to actually remove them from my visualization, but I'm not worried about that, as I know it's easy to get them back if I want to look at them again. So now I have my stations. I want to focus mostly on the south, so I'm going to take out a couple. And now what I want to understand is the various bike traffic across all of these stations to one another, and then also within a given area. So I'm going to select all of my stations, and I'm going to use my get ride days action to calculate all of the rides between any two stations and get me back all of that data in a way that'll be nicely visualized. So right now, Hume is reaching out to Neo4j, calculating all of this data, ultimately to bring it back into the visualization so we can start to look at it in a more analytical kind of way. So this is a bit of a mess at first because this is all kind of the days for these stations. So I want to filter this down a bit based on a temporal element. So here I have my temporal analysis section where I am going to use my time slice by day. So I have my time bar enabled, and now I have a given day's worth of data for any given slice. I can turn this off and get down to actually the individual hour or minute if I wish. So I can actually zoom in here. But today I'm just interested in a day's worth of traffic. So this data in particular is for January 1st through the 31st of 2022. So let's go ahead and take a look at January 1st. So this is New Year's Day. So I would say this is a bit of an outlier when we're trying to understand how traffic patterns arise in this part of the city. So we can definitely see some heavy traffic between kind of the southern regions and up into this kind of station 101, 103, 105 area. Also seeing some traffic moving towards 101 or 401, 402 area. But now let's kick off our time bar and see how this traffic pattern evolves over time. So we can see quite a bit of traffic moving to 101 and also across from Jersey City up to 101, but also a bit over to this kind of 408, 401 area. So it looks like they're moving both northeast and a bit northwest. And we're seeing, once again, more traffic towards 101. So at this point, I want to kind of understand what am I seeing here? What pattern is this? And why is this 101 terminal so significant? So I'm going to zoom in and take a look. And one of the first things I notice is that this is the terminal closest to the Hoboken Ferry Terminal. And us being in Jersey City, this makes sense because everybody's using the Hoboken Ferry Terminal to commute in to Manhattan. So let's try to further verify that hypothesis using some other analytics. So within Hume, we believe that knowledge graphs are an excellent way to analyze data, but we also don't believe it's the only way. We still believe that knowledge graphs are most powerful when used in conjunction with all kinds of other traditional analytics methods. So in that case, that could be something as simple as some traditional charting. So what we've done is we've built this into where we can actually get a distribution of ride volume across different hours of the day. And so for our Hoboken Ferry Terminal, this makes a lot of sense. We see a lot of rides ending early in the morning and then starting late at night. And that tracks with our hypothesis of this idea of people taking a bike, ending at the terminal so they can then get on and then go into work, or going to work, coming back, and then starting their bike ride home. So this, I think, definitely tracks with that idea. And then beyond that, one of the things that we found is very useful, especially in geography use cases, is the idea of getting boots on the ground to understand when something might be the case. So in this case, what we've done is actually integrate Google Street View via an iframe so that we can actually dive directly onto a given area and take a look. So in this case, there's my bike terminal. I can actually see my individual bike terminal here, and I can visually investigate, okay, maybe I've got an issue because it's inaccessible or something like that, or there might be a major event nearby. And so in this case, I can see, all right, I've got a couple car parks nearby, that's good. And this looks like there's plenty of crosswalks to be able to access it. We've got a nice street light, so I'm going to say this checks out. But I can also repeat this analysis for any given terminal. So 401 stood out as a particularly active terminal. So let's take a look at that. So we can use our street view here. Once again, we can see our bike station, and overall this looks pretty good. I can also repeat the same kind of analytics. So I can get my statistics on my rides, and we get a similar kind of distribution. Very cool. So now that I have looked at the various data behind these this terminal traffic, let's take another look at our traffic to see where we might want to build these bike routes. So I'm going to go through a few more days of traffic. So once again, 101 really surfacing most of the traffic here. And at this point, I feel pretty confident in knowing where I want to build. So I think that most of what's happening here is that I have traffic going from Jersey City up into Hoboken, so ultimately they can take the ferry across. So I don't think this is a case where I need many new bike paths because there are a bunch of people going to a bunch of different places. It seems that there's really one destination here, and that's this 101 or 103 terminal. A little bit also to the 401. So we want to also take those into account because it's obvious some people are also moving up into kind of the west side of Hoboken. So in this case, I want to pick kind of a happy medium. I know I can't necessarily build a route directly to HB 101 because there's this nice train yard and part of the Hudson in the way, but I also want to make sure that I'm also directing some traffic towards 401. So I'm going to kind of pick something in the middle, which is this 409 station, and then I want to connect that again to something very central, which I think would be this JC 82 terminal. That will kind of give me a nice direct route from kind of central Jersey City up into Hoboken. So now I'm going to use my underlying H3 hexes and then build a shortest path between these two stations. And what we get is the H3 path for these stations. So now I know exactly where to build my path. I can see that there's my main thoroughfare here to utilize, and I can easily build a route between these two. So I hope this has been a great look at how you can utilize some of Hume's features, specifically pertaining to geography, in order to help solve for some of your geographic graph problems. I hope this has been helpful. Thank you very much.